All right, welcome to our session. The point of this session is really to give you an overview of built-in AI. We've been at it for about 1 year, maybe a bit more than that. I'm Kenji, I'm the product manager for this effort, and this is Etienne, my engineering counterpart. So mostly going to be an information sharing session. We do have a few open questions, and hopefully we have time for a short Q&A at the end. So I'm going to share some context about why we feel that built-in AI should be a thing. To unlock client-side AI. All right, next. So you might be thinking, well, like doesn't client-side AI already exist? And yes, there are like frameworks like MediaPipe that you can use to do AI, including LLMs. There's a big problem with LLM. There's like huge downloads to just get the model to begin with. And also it's very hard to know whether that model can work on user's particular device, or if it's not going to work at all. Next. So if you think about how many websites you typically visit in a week, like maybe we are a bit on the higher end, like it's probably a lot. And if you fast forward to max AI adoption, every single website would start to download an LLM, and clearly that doesn't pan out. So it would be like gigabytes of data for each website, not good for your data plan. It's going to fill up your hard drive. And next slide. For developers, especially if you are like a starting developer, it could be quite expensive as every user is going to download gigabytes of data from your website. And so if you didn't expect your thing to be popular, you are going to see your bandwidth bill like go up very quickly. Next. So in a sense, client-side AI, it can be done, but it's not yet always practical. And this is where built-in AI can help. So next. If you imagine a shared LLM that all the websites and extensions can access without having to download one, that is essentially what built-in AI. But that's not all. Next slide. Built-in AI is really the combination of two things. A series of models, including an LLM, but also expert models, LoRa's, fine-tunings, and high-level APIs so that it's super easy to take advantage of those models. So essentially, if you tell us what you want to play, we handle the rest. We are going to pick the right models, optimizing the performance and the quality. And over time, as new AI models comes in, we can take those models, bring them into Chrome, and you don't have to worry about that. All right, next. So that's the architecture, but what do developers really want to do with that? And to answer that question, this is what we did. We started with a prompt API for Gemini Nano. And the reason why we started there is because that's the most flexible options to explore the space. You can send anything you want to the model, get something back, try a bunch of use case, see which one the models can pull off, and then tell us what is exciting versus not. And because of that, we were able to work with partners across 8 different countries. We did a 1-week-long hackathon with 50 incredible prototypes, and we learned a lot from that. Next slide. So each point on this map, we present what our partners use client-side AI for. You can see that it goes from summarizing articles, detecting sensitive information, the various applications for writing scenarios. Next slide. So because of all this like interest, we decided to move to the next step, which was building the whole thing, not just like a shiny toy that you can play around with it, and trying to do something for I/O 2024. And despite all the odds being against us, we managed to do it. We had 6 incredible use cases, 2 partners demos, and we were able to announce the development. Next slide. So that developer preview went live in May, and over time, we've seen about 15,000 developers join this program. So I've never seen that, so much interest. And what we did is essentially give sneak peeks of the APIs that we wanted to build, get some feedback about that, and working together to improve the API shapes and also refine understanding of what is really like the set of use cases we should focus on. Next slide. And so through a series of like surveys and interaction with this group of developers, we got a bit more information about which use case most people were interested in. And so as you can see on this map, the bigger the dots, the more demand there was for that particular use case. And using this, we decided to prioritize a few APIs that were targeted at those specific use case. And as part of doing that, we also realized, you can click, that there were like some need for additional language, some need for additional APIs, like the language detector API to go with the translation use case. And we also decided to keep API, starting with a Chrome extension scope. We can talk more about that later, because we felt it was still useful to have to let the developer continue to explore the space. Other use cases I'm interested in. All right. So this brings us to the present time frame, and our approach is still to continue to do product discovery, and also like have reality checks, because we're not just going to take all the use case that comes our way and say, let's do that. We need to be a bit more like careful about what we do versus not. And taking this approach of like iterative design, where we launch something, it's behind the flag, people play with it, they tell us if they like it or not. Then we move to origin trials, we get a bunch of feedback, we go back to the API design, we improve the quality and the policy, and eventually we launch. All right, and that's what we are doing. Like one example that just came up recently, maybe you need to click this thing. One more. Yes, it's not in right order, but we recently published an explainer for a proofreader API that was that came into the picture because we had early discussion with potential partners and they were interested in that. And what we did was, can we get Gemini Nano to be good at that use case? And we have confidence that it can be done. So that's why we started to design an API for that use case. Next. I think here, MapQuest is over, and it's time for HN to talk about the actual APIs and so on.
All right. So first off, as we discussed, we have the prompt API. That gives you direct access to Gemini Nano. It's very easy. You send prompts, you're going to get responses, and then you experiment with it. It's been available in Chrome since Chrome 127, and it's been in origin trial since Chrome 131. And we're starting with extensions, and TBD when we're actually going to ship this API. Next up, we have the Summarizer API. So if you want to summarize some text, but you don't want to deal with prompt engineering, that's why we have this API. You can condense long text into bite-sized summaries. It's perfect for TLDRs, bullet points, catchy headlines, whatever you want. And it's been ready for prototyping since Chrome 129, origin trial in 131, and also shipping is TBD. There's also the language detector, and Christine did a lightning talk yesterday about that. So if you want to quickly detect the language of a string or paragraph, that's why it's there. So you can identify the language of any text. It's perfect for translation tools, content moderation, more. Also available for prototyping since Chrome 129 and in origin trial since 130. Shipping TBD as well. Translator API, well, that's the continuation of the language detector API that Kenji was talking about. So figure out the language of a string is great, but maybe you want to translate it. That was the next logical step, and that's what we did with the translator API. So just a few lines of code, as you can see here, specify the source language, target language, what's the string you want to translate, and then easily you can just translate the string. All of that is happening on device, which is really great as well. Want to mention that again. It's been available for prototyping in 129 and in origin trial since 131, shipping TBD as well. Next up, we have the writer and rewriter APIs. So if you want to have effortlessly and effective writing, very easy. Any websites can integrate them and help their users polish their prose or blast through the writer's block. Easy to see use cases for that if you're in WordPress and any blogging platforms or any posting social media platforms. Easy to generate content there. It's still behind the flag. We've prioritized other APIs, but we have origin trials soon. We're trying to get there, so that's also coming. The last API that we have today, it's a proofreader API. So we published the explainer. It's joining the ranks of the writing assistance APIs, and we started working on an experimental implementation, still in development. But here you can see in the GIF the basically what it can do. So it provides you with the ability to see the mistakes, different types of mistakes, and offers corrections. So really powerful API, and likewise, this is all happening in the browser. So at this point, you probably have one question. Are developers liking those APIs? Kent, you mentioned that there's over 15,000 people that were interested in joining in using these APIs. And what's the feedback so far that we're going to get into? So as you can see, the overall satisfaction is pretty high, I would say. And we want to bring this higher as we improve the quality and performance for summarizers specifically, for example, because we can and we know we can fine tune Gemini Nano even more to be even more performant for those use cases. But one thing I really want to highlight in this is the usability and design of the API is very high. There's been a lot of work done by Dominic Denicola and the community or partners to arrive at an API shape that is very intuitive for developers to use. And that's the feedback we've gotten. So that's really promising and exciting because what we need to work on now to make the APIs even more performant, that's something we can do in the background. And over the next few months and years, as we make improvements to these APIs, you can expect that satisfaction to go up, and the API shape will stay the same. So I think that's a pretty powerful thing that we have here. All right, so we're in the final quest. I think we've made some good progress, but there's still a few big things that we need to discuss and address. And that's what we'll get into in these next few slides, and then we'll turn this into a discussion. But yeah, we're going to be curious to hear about your questions and concern about this area. And yeah, so let's start with the first thing. One thing that we have in mind is, okay, like we said, the prompt API is available only for extensions right now. What if we were bringing the prompt API to the web? What would be the problems with that? And I think when we were talking to developers and partner, their first reaction was, oh, wow, yeah, I want that. I want the prompt API. They're excited to use it. Then their second question is, okay, will this work in different browsers? Will I be able to use that everywhere? And that's where you get into, you get excited about one thing, you prototype, and then you actually want to use it in production. You need to think about these things. And it is a challenge. Browsers will be choosing different models. And so we think they're high level, like there are more problems than that, but high level, there's two main problems that we see with the prompt, and that's what we need to solve. One, you'll need probably to write one prompt per browser due to the fact that they'll be choosing different models or LLMs. And second is that the response provided by the prompt API will be different and could be hard to parse. There's no guarantee that the LLM will respect your output format. And we think that standardizing the prompt API, like what's accepted and what the result should be, is probably not realistic. There's so many things that you can do with the prompt API that forcing certain things into the browser is probably not the right idea. But then we also think that maybe having developers write one prompt per browser is not the end of the world. It might be, a price to pay to get the prompt API on the drive-by web and unlock developers' ability to do AI on the web and not elsewhere. But I think the main concerns that developers will see is what I talked about is the output. And I think that's one thing that our partners at Microsoft have been helping us deliver structured output. And that's the ability to enforce and impose a JSON schema as a response. So basically what we're saying is we believe that with structured output, the benefits of the prompt API probably outweigh the inconvenience. And what you can do is at least expect a certain response schema. The content might be different in it, and then you need to tailor your input per browser. And I think why we think this could work is because we think that enabling the prompt API on the web will unleash developers' creativity and will come up with real use cases that we can then turn into task APIs. Maybe those can be standardized more easily. If you want to summarize, there may be a bunch of things that you can do to say, here's how the browser should behave. And maybe the prompt API in developers' mind is more open-ended. You expect things to work differently across different browsers. But yeah, we believe that maybe having the prompt API on the web outweighs its costs. And on the flip side, we'll be asking you what you think and what your thoughts are. Kenji, I'll let you.
And to build on this idea of like finding ways to make the system more open and let people explore the space and identify new use case, one thing that I'm particularly concerned about is this idea that the built-in AI right now is really like a 1P only solution where we get to choose the models and the use case and the APIs. You have to wait for us to prioritize your use case. I would like to find a way to remove that. And so in particular, for instance, maybe there's a way for us to take on more AI models that we can share across Origin so that you don't have to wait for us to identify your use case and decide it's a priority, find the right model for it. There is also a limit to what we can do as a team compared to what the whole ecosystem could achieve. So there is a session for that. I think right after that one, we can spend a bit more time on that topic. Yeah. I think that's it. So I think these are just a few examples of requests. If there are questions, also.
How does it technically ensure that the generated result matches the structure? Like, what's going on under the scenes?
Yeah. Okay. So basically, I'll say this at a high level. I need to get exactly familiar with what exactly is happening at the LLM level. But my understanding is that we're enforcing a schema, we're respecting a schema, and if the token doesn't match the expected and the JSON schema would be invalid, we're asking the LLM to regenerate token until it matches what the expectations. Oh.
I can answer that too. So we're using a library LL guidance, and what that does is takes the JSON, parses it into a grammar,
Yep.
and so it knows what possible tokens are. Possible tokens are the next token, and so the output of your LLM, it masks out the tokens that can't be the next token, and then you sample on that, and so you only end up with something that will adhere to the schema. And if it doesn't adhere, it'll tell you that you're no longer within the schema, and so you can throw an exception. When you feed in the JSON schema, it parses the schema, and if that fails, you can raise an error as well. So it adds some formal like validation of the schema and ensures that your outputs adhere to the schema. And even for models that aren't really good at emitting JSON output, it steers them in a way that they produce JSON output. Nowadays, the models are pretty good. If you stick your JSON schema in the prompt itself, it does adhere to it. But if you do things like required fields, that's something the model may skip. But when you use LL guidance, it enforces that the required fields are filled out.
Does it support any kind of backtracking to like correct schema errors that would require going backwards a few tokens and then trying a different path?
Don't think so. All it does is in the logits, it masks out logits and lets you sample on it. So there's no way for it to tell the LLM, go back and redo things.
You mentioned one prompt per browser doesn't sound so bad. And then I think of like WebSQL, which is like a fraction of the problem of, everyone has ossified on the specific variant of SQLite. And how can I move it? So what is your thinking on, how can Chrome switch to a new model down the road if one model per browser, or, one prompt per browser is A-okay?
I think when it comes to changing the model, there could be scenarios where the prompt doesn't work as well as it used to be, and you need to further update it. But I think it's part of the value of the prompt API is that it's more flexible. You can do more than using the task API. So it has some downside, which is more maintenance, more burden. Hopefully over time that gets lower and lower. I think over time we're not going to update the model as often as we are going to be updated because like innovation tends to slow down over time. So it depends on where you want to draw the line. Like, do you really value that use case and are willing to pay the price for it? Or would you rather do something on the service side where you have more control with other downsides? So I think it's all trade-off. Like, that's my take.
Yeah, and I think it's part also of the whole ecosystem of AI on the web. Like, if you have a specific use case and you want to bring your own model, that's also something we're looking into allowing you to do. I think it comes with the cost of not managing your own model. You run the risk of things changing, but it's definitely new to the web, that's for sure. But we're not. That's the point of the prompt API is we're not forcing a behavior. And it could mean that, at some point your site could not work as you think or as it was working. So
And I guess one quick follow-up is like network protocols sometimes add grease, right? Which is, something that forces site developers for servers to think harder about, what kind of things they're hard coding. So just that would be, hey, if Chrome could sometimes have a different model with different characteristics, and maybe if you could encourage writing more generic prompts that work across multiple models, might be an interesting way to kind of limit the risk both for other browsers, but also your own on enabling model evolution.
Or maybe longer term, you can like have the model translate the prompt into other models.
Pretend you are Gemini. Answer this. Oh, no.
That's it. I like, you need a bigger model maybe to do that, but I do find
but it's a
myself,
one-time task, right? Like
Yeah.
you do that as a developer.
I do find myself asking the bigger Gemini model to simplify like very complex prompts so that a smaller model could do
Yeah.
something with it. And sometimes it helps, sometimes it doesn't. It's a bit hard, but it's a good trick sometimes.
How deterministic are the outputs? I can imagine this being good in some scenarios and bad in others. Like I would imagine for the proofreader, having the same output every time would be desirable, but maybe for the prompt API, having different output every time might mitigate that issue.
Yeah, I do think we expose the temperature for one and also the dot K parameters, so you have some control over that. In general, if you want to drive some logic out of the output, I think it's better to use structure output for one and maybe a lower temperature so that there is a bit more consistency.
What are the kind of hardware requirements for this? And like from the performance point of view, if things would have been done in native versus in the web, do we have some kind of timings of those APIs?
yeah, I'm not sure I have data to share right now, but it does require GPU right now for Gemini Nano to run.
And when we say GPU, it doesn't have to be a fancy NVIDIA like discrete card. Most modern CPUs have a GPU that is more than capable of running it. The biggest bottleneck is the amount of VRAM, because we do want to keep some margin for other things than AI. So there's that. But the team is working on exploring like actual ways to bring that down, increase the reach.
Okay, thanks.
Are you doing one model for all of these use cases, or might you load different models for different use cases? Or, I mean, I know it doesn't. You could change it in the future, whichever way we go. But.
That's also part of the like the appeal of built-in AI is that we get to manage that behind the scene. And so if we do find a model that is smaller, that can run on more devices, that can still deliver good quality, that's something we could do.
Right.
You found that developers want a minimal, say 20%, 30% hardware coverage before they engage with the APIs, or do they not? Are they okay with working bleeding edge?
Yeah, I think it depends on the market and the partner. Like some partners are really eager to try the new thing, especially if it let them add features that they really care about, even if it's like initial like small reach, because a lot of them understand that that's the step you need to take in order to get more, like especially like cross-browser as well. You want to show what's possible so that people understand that there is potential and therefore maybe it's a good idea to prioritize. So it depends on the partner. Some partners really want to wait for like, it has to be on everywhere, like every device, every browser before we do anything with it. Some partners are like, let's just do it.
Do you see them looking at this as an exploratory thing or something that they are thinking of doing in production and getting more feedback?
There is a mix of all of that. Some partners are more than happy to try something in production, even if it's not always available for everyone. Other partners just want to do an experiment, provide some feedback. All of that is like valuable, especially in the early days. Like obviously production is better, but we'll take anything.
Do you have any thoughts about these developers you're working with and encouraging them to try with other browsers if and when they have similar APIs to test the interop claims?
They're asking us, oh, can you convince other browsers to ship the APIs? So we're trying to, engage in W3C WebML working group with other browser vendors to, explain the benefits and how partners are excited. Also trying to get partners to go public and say publicly that they want that, not to support Chrome, but to support the web. Sometimes they're worried about like picking a winner, and we're saying, no, just say publicly you want all the browsers to support these APIs, and that's your use case. So we're trying to encourage partners to do that publicly. So yeah. Good. Yes, Ken.
If you compared the results with the on-device models to like a server-side model and just seeing the quality differences, and where are we on that spectrum, assuming that the server side is like the best we can do?
Yeah, I think that's also why we want to be mindful about the use case we pursue, because Nano is not going to be as good as what you could choose on the server side. Like the size is much smaller. That being said, I think for summarization, unless you go into like very domain specific like text, what we've seen is that it is pretty good to begin with. And as I mentioned, we also are working on improving the quality of the use case by using fine tunings and ROAS. So over time, the model is going to get better, our fine tunings are going to get better. And we want to make sure that the summarization Flask API is good for a good chunk of the summarization use case. It's not going to be 100% perfect for everything.
We're starting to see some multimodal models come out, recording like images, possibly voice.
Mm-hmm.
Is there any thinking about starting to delve into those?
So what we've been doing is that we already knew that Gemini Nano was multimodal. We haven't prioritized that just yet, but we wanted to make sure that the API ship could take that into consideration. Mm-hmm. So you might have seen some multimodal things in the explainer, and this is what this is about. It's making sure we have a path.
Right. I could see some really cool use cases with that.
You share some use cases for a multimodal.
Like making an interface that you can talk to, and it can use the model to figure out what actions it should take based on the thing that you asked it to do. I think that would be really useful for a lot of applications.
I think there's a web speech API, so that part of it conflicts with an existing API. So I'm trying to understand.
So web speech is the computer talking to you, right?
Both. It has both speech recognition and text to speech.
Right, but also the recognizing the audio, I think, is going to be higher quality than converting your audio to text, feeding that to an LLM, and then using that to drive the actions.
Okay.
Yeah, that's my understanding is that's generally what people have found, is that both directly consuming and directly generating audio is higher quality than attempting to transcribe.
Exactly.
Or convert to speech.
I think the current small language models don't do speech output. They do text output, but speech input. Mm-hmm. With speech output, it could capture things like expressions, which weren't possible with the speech thing.
Yep.
I'm just wondering if it's worth increasing our model size for these maybe niche scenarios if there are not enough use cases. Instead, we should focus more on the text scenarios and make them more smart there.
It's hard to say what's going to be more valuable, but like, as you make these things possible, people will use it, I'm sure.
Yeah. One thing we've seen with the translation use case is that we had the choice between using Gemini Nano or like expert models, Google Translate models. We decided to go with the latter because they run much faster, they run on many more devices, and at the time the quality was much higher with those. That being said, there are use cases where an LLM is actually the better choice because you can tell the LLM to follow some instructions when it does the translation. You can't really do that with the expert models we have. So there might be a range of use cases where even if the quality and the reach and the performance is better with like simpler models, you might still want to go with an LLM because it can do things that those can't do. So there might be like different flavors of an API only a parameter we say that's the variant of the use case that I want. It's not pure translation, it's more than that. So maybe some similar use case could arise for the web speech API.
I had a question about the consistency of results between different models. You can imagine that different versions of models could give you different results, different models on like Android or web or like mobile devices in general versus the web could give you different results. I'm curious how you're thinking about it. I mean, it doesn't feel like a solvable problem, but I'm also curious like what we should communicate to people using the APIs, like or general thoughts around, you know, how to either constrain it or how to communicate that it's expected.
Yeah, so we do think that the task APIs hopefully should provide similar results for what you're trying to do, and that's what we're trying to optimize for. And I do think maybe I'm naive, but over time, I think the community could come up with some smart prompt engineering for browser to achieve what they want. But I think right now we're focusing on optimizing the task APIs to be as precise as it can be.
Yeah, the other thing is maybe for some use case, again, using structured output could provide consistency. And then you could also imagine a pattern where if you have a set of scenarios for which you understand what the response should be, you could try that, confirm that it's going to work out, like a way to mitigate, or the models has changed. There needs to be a way to confirm that what we had so far is still going to work. So you could run a bunch of scenarios on the device before using it, confirm that it's responding the way you would expect it to do. That makes sense.
Well, yeah, I guess that is parallel to how we do feature detection. Like you write something small, you detect it, and then you see that it's working as expected, and then try to run your applications.
There's about 1 minute till the next session. I start to see people outside the room. So
Yeah, we
Yeah. And that's probably the whole session as well.
Yeah.
I guess. Yeah. Thank you.